All right, I think we will start. Hopefully everyone was able to join, but we will have this recording, so that will be all distributed with all the attendees. So welcome to today's webinar. I'm really happy to go through our new feature, Adjust to Control, that is part of GeoSLAM Hub and Draw 6.1 release that has been released a few weeks ago. Hopefully some of you got the chance to use it already. And today we will focus mostly on Adjust to Control. However, I will mention a couple of other things that are new in that version as well. So just a couple of things that I wanted to just mention at the start. I will keep you all muted during the webinar. There are quite a lot of you here, so I think that will be easier that way. And then, of course, we will have time for questions and discussion. So please pop any questions that are coming up to your mind during the presentation in the chat, and I will be reading them out at the end of it. Hopefully we can answer all of them. If not, we will follow up and I will contact you directly about any other questions that are not answered. Okay. So just to introduction from my side, as maybe some of you don't know me, my name is Joanna Setkovic and I work as an application engineer in GeoSLAM. I have been with the company for almost 3 years now, and previously with a sister company, 3D Laser Mapping, where I had a lot of experience with mobile mapping systems and installations and trainings. And here I've been specializing in all of our ZEP products, UAV applications, system trainings, demonstrations. So some of you might have met me on site. And since a couple of months now, I've been working with product development and new improvements and new product delivery to you guys. So to give you an overview of the content for today's webinar, I will, sorry, I just thought that maybe someone did not hear me, but okay. So the content for today's webinar is, first of all, overview of what is new in GeoSLAM Hub and Draw 6.1. That will be short, so I'm not going to go in detail at all on this. And then focusing on Adjust to Control, which is a new feature that is available in that version. So overview for that, data capture, data processing, some of the recommendations, data set example. We have a couple of data sets already captured by ourselves, but also by our dealers and partners. So thank you guys for that. It's really, really useful and helpful for us as well. We will also have a little bit of accuracy evaluation on how actually that tool influence the data itself. Then I would like to go through the hub and actually show you the workflow so that you see step by step what needs to be done. We also prepared quite a lot of technical materials, so I wanted to point out to you where that can be found. Few frequently asked questions that can maybe come up in your work everyday life, and then the summary. And as I say, any questions, please pop them in the chat and we will talk about them as well. Okay, so just an overview of the new GeoSLAM Hub version 6.1. 3 main improvements. So obviously Adjust to Control as a new feature, version 1 of that tool. We integrated the newest GeoSLAM Draw. It's version 3.5 now. All of the release notes and actually also quite a few new videos are available on that version of a Draw on our Academy. Again, I will point that to you as well later. And a couple of improvements in processing and a new parameter for processing the data in GeoSLAM Hub. So I want to first start from those small things which we will not be focusing on during that webinar, just to give you an overview, and then we will progress to Adjust to Control in depth. So GeoSLAM Draw 3.5 comes with multiple improvements and changes to processing and handling the data. There are quite a lot of improvements how the panel images are handled and displayed, how the different modes are switched and used by a user. There's a good bunch of improvements in vectorization, snapping to the closest line, a couple of things that will be useful in vectorization. We are also offering a floating license from this version, which is for 30 days offline a possibility to use draw. After that days, user has to connect to the internet to reset the time. As I mentioned earlier, there's a lot of information on that new version on Academy, so please have that in mind if you want to find out more. Second thing that I wanted to make sure you are aware of, as it's not surprised, there is a new processing option in Hub. It has been added to the local part of SLAM, and it is only available for ZEP Horizon dataset. That is specifically for ZEP Horizon systems. It's optimized laser position, and it is optimizing transformations between the mount and laser, as it is shortly described here. To summarize of that, just shortly, it is improving mounts between the transfers between the mount and laser. It is disabled as default, so if you drag and drop your Horizon data, that is not going to be applied. However, I do recommend to change that setting in advanced settings, where you can preset your parameters before dragging data. So in advanced settings, override file for Horizon. You can turn this on and have that on at all times. Specifically for ZEP Discovery users, that is very recommended to have it on, and it will help to have better camera calibration with the point cloud. It can also help in some instances of issues with the Horizon data set as well. So definitely a useful parameter to know of. So this was really quite short introduction of those main things that have been added to the GeoSLAM Hub 6.1. And now we can focus a bit more on the just to control. So firstly, in overview just about the feature, just a few points, because some of you might not know at all what that can do and what is the application for it. So firstly, to mention who can use that feature. All users that have a valid GeoSLAM care contract can use adjust to control. They need to have 6.1 installed, as that's the only version that supports that feature. And reference plate has to be used for that system if you want to use adjust to control. Adjust to control, in a short, enables to use externally measured ground control points to calculate transformations on your process data set. It has to use reference plates to mark those control points while scanning. And it can be used for all of our handheld devices. We do offer two types of transformations or adjustment. It is a rigid transformation and a non-rigid adjustment. And a little bit more in depth about those transformations and adjustment, I will go in. I will show you in a couple of more later slides. So just going to data capture. The main thing is to remember that the known control points are supposed to be observed with that reference points installed with your handheld device. The system has to be positioned upright and kept stationary for at least 10 seconds on that control point. It is quite important to keep it as stable as possible, because that can influence the accuracy of the control points and of the reference point detection. Precise coordinates of those control points should be obtained by different surveying methods. So it can be GPS, it can be total station, anything that can give you coordinates of those points in your desired coordinate system. Reference points are automatically detected in our scan in local coordinate system, in the scan coordinate system, while processing data in Hub. Of course, I will show you the workflow, but here just mentioning that then user needs to import or enter those files into the feature in the user interface, which is also integrated in Hub, and the new altered scan will be produced that fits that data to control points. Couple of recommendations that I wanted to mention. Definitely, we still recommending and stressing out that the SLAM best practices have to be followed. if it's possible to close the loop, close the loops and follow all of the best practices. This feature is not going to be able to correct any major bigger drifts. It is there to produce a georeference point cloud and correct some part of a global SLAM. I will get to the processing stage in a second as well. A minimum 3 control points are required, but definitely recommend to use more for a contingency if the reference point detection is not successful on some of the points. Definitely try to keep more than 3 points per project to perform the adjust to control. The control points, the adjust to control has the biggest impact around the reference point that is used. As further away from the control point you go in the data, the less impact that the processing will have on the point cloud. So you might want to sometimes think about where to place control points and perhaps place them more in the area that you want to control more rigorously. There is some general rule for density, but I wouldn't keep that in mind and use it at all times. It does depend on the feature environment, on the environment and how many features you have and what's your path of walking and scanning. We have tested a lot of data sets captured every 40 to 50 meter control point. That worked pretty well, and we could see good improvements. We also have capture data that had the control points placed every 100 meters, and that in a good range feature environment would be working fine too. So for reference, just if some of you don't know much about the reference plates, I wanted to show you the picture and actually a couple of information that might be useful. So as I mentioned, this feature in that version of software, we are only working with reference plates to mark those control points, the reference points. And there are 2 different reference plates for systems. For Horizon, there is a one type, and for Revo and Go would be a different type of plate, different size basically. It is important to use the correct one because the offsets between the control point that you are marking and the actual trajectory, so the center of the scan, it's set by those reference plates, so that will have to be used correctly. And as I mentioned, during the processing, those control points are automatically then detected, but you need to make sure that you are placing the system stationary and stable for that period of those 10 seconds. So here is, because I've already got quite a lot of questions about the reference point, so I thought that I will mention this a little bit more in depth from a technical point of view. There were quite a few questions about different orientations of Horizon or Revo, if they can be used on the wall or with a slope control point. And here is just that a bit of explanation on that. More in-depth technical explanation is found in the user guide, as I knew that this is going to be a part of it, so we did prepare for it, hopefully good enough. So with Revo, RT or Go, that control points can be only placed on the ground, so those systems have to be upright, level to the ground, and the reference points cannot be detected with the slope or on the wall with those systems. Those Revo, RT, Go, and Revo systems have dynamic transforms, and what that means that we don't know exactly where the base is, and we assume that the base is flat underneath, and that's how we can offset the center of a scanner to actual point where the markers on the reference plate is. So the star that I've showed you here, the star of on that reference plate is where you have to mark the control point, and that's where you will provide the coordinates of control points to. So that's how we need to bring our coordinates from the center of the scanner to that point to perform the translation and rotation. So Revo, RT, or any Revo or Go systems cannot be used on the walls or other tilted surfaces. It has to be placed on the ground. Any deviation from that vertical position will influence some accuracy of the detection of the reference points and how we are applying those transforms. Whereas with ZEP Horizon, it's a little bit different because it has a different design. We can use that system on the ground as standard, but also on the wall and on the tilted surfaces, because we have a fixed transfers and we always know where the base is and how it is inclined, so we can then calculate from that how to apply those transforms. And as I said, in that version, the transforms are applied automatically for Revo or Horizon in the software. So only reference plates can be used at that stage of that tool. This is just to give you an idea, because I know some of you guys are more visual. So Revo RT Go has to be placed on the ground and align with the star has to be aligned with the control point on the ground in the vertical position. Whereas the Horizon, that can be used in two different, well, here is just shown two different, but you can understand that this means that you can tilt the horizon to record the reference point. Obviously, for example, recording reference points on the wall, it is a bit more tricky because you need to make sure it's stable, and it is a little bit in an uncomfortable position to hold it, but please make sure as stable as possible that you are marking those reference points, especially on the wall. Okay, so now going a little bit more in the actually detail of the transformation and adjustment that we offer. Rigid transformation, hopefully the name itself speaks for itself, but it is a single transformation to every point in a point cloud. It will move all of the point cloud, rotate and move it to the new position, but the relative positions within the point cloud will not change. So the sizes, the calculation within the point cloud will stay the same. It will just move the point cloud to fit the control points provided. It is a 3D transformation, but the rotation is only around your axis. So there is a 4 degrees of freedom for you, for those of you that want to know that in detail. We are not applying any scale factor, so we don't calculate any new scale factor while performing rigid transformation. Non-rigid adjustment, so this is on purpose changed to adjustment because it is not simple transformation. Non-rigid will move all of the points in all of the point cloud to the new position and orientation, so it will basically perform a georeferencing. However, it will also change the relative positions of the points within the point cloud. How we do it, we are using the control points that the user provides, and we're using them in the global SLAM calculation as an additional constraints. That's the option in SLAM, that you can use some additional points with the non-coordinate system and perform another calculations of global SLAM. So it is not, processing all of the data from the start. Local solution will be the same. However, global SLAM, the end adjustment will be changed by that constraints. The main difference is observed around control points, so that's already mentioned before. As further away you go, the less influence there will be of adjust to control calculations. Non-rigid adjustment is 3D adjustment with 6 degrees of freedom, so we can all manipulate in all directions. This is all the next few slides. They're all more in-depth explained in the user guide. So this is not I'm not gonna be getting into detail that much. But control points have to be stored in a text file format with a tab separation in it. So, okay, the format is stated in the user guide. We will be working, of course, on getting this improved and add more formats to it. And that's why also I do want to hear a lot of feedback from you guys, what you're using, how the workflow works for you. Control points have to be in meters. We do not support US feet. All of the SLAM calculations, the core of the processing is in meters. So we are not able to change all of that to import the US feet. However, we are thinking about some additional calculators that maybe will be available in future, or user at the moment, everything has to be calculated in meters, and then at the end, some other tool may be used for calculations transformed to US feet. Okay, so as I mentioned earlier, scale factor is not applied, and we do recommend, if possible, to use a local or flat grid, but this is more to do with the large, bigger scale projects. So with data processing, we have integrated an interface in GeoSLAM Hub. It is available from the main menu, and I will show you that hopefully shortly on the demonstration. We have RMS values available for each control point that you are using, and the overall RMS value for the calculation. You can export a LAS and a trajectory after performing rigid or non-rigid adjustment. And you can also export accuracy report, which then can be used in your calculations further down or reporting. As a final output, you will see a point cloud that should feed the desired coordinate system. So this is, for example, in UK National Grid, our office in Nottingham in UK, processed through adjust to control. With the processing recommendation, definitely a few things to mention is that you need to process data correctly through SLAM first. So if there are any bigger drifts or any problems in the local SLAM, adjust to control will not be having any influence for that. So that has to be then processed correctly through Hub with some additional different processing parameters and so on. We can compensate for only small amount of drifts, and the influence is really in the global SLAM. So we do see a lot of improvements, which I'm going to show you a little bit actually as an example on open loops potentially. If you do an open loop, if you don't close the loop, the global one, I mean, there is a good influence done by adjust to control for that global drift that can occur in that instance. Non-rigid, of course, has a greater influence on open loops, so we will see much bigger difference between the rigid RMS and non-rigid RMS for open loops, because open loops will essentially have a bigger global drift, and that's the whole reason of closing the loop is to limit that drift that can occur. Of course, the results of the adjust to control will differ, and there's a lot of factors that can influence it. Main things, accuracy of control points. We have actually tested quite a lot of different sets of control points with a different level of accuracy, and that is quite significant difference. And you can even, if you are using very low accurate control point, you might see some problem in the point cloud as a result from adjust to control. So this is quite important to have a good accuracy control points. And obviously reference point detection is important, because if some of the reference points are not detected or not detected correctly because of the movement during that detection period, then those control points might not be good to use. That's why it is good to have more control points than needed, so that you can maybe play with excluding some of them from processing. So here, just to give you an idea what general workflows we would see that can be used with adjust to control, but that is really open to what and how you want to use that. So standard georeferencing, of course, you can use rigid, especially if you close the loops, if you keep all of the best practices for SLAM in place. You just can perform rigid transformation and have a georeference point cloud as a result of it. With adjusting SLAM results comes non-rigid adjustment. So that is where you are actually adding GPS points as a constraints to global SLAM. And that it has the biggest impact on the open loop scans, if you do scan something like that. There is an idea, and we have started testing in the direction of merging multiple scans. So using reference points from one scan to be a core reference, and then adding them to the next one and next one if common control points are marked during the scan. Some of the data examples that we have had so far, captured and successfully processed through adjust to control. City mapping and road mapping, quite a few examples either by ourselves or by our dealers, where we wanted to see the impact on the open loop. So here are a couple of scans around the housing estate and the office estate as well. Closed loops and open loops are working quite well, both of them. So the top one is the closed loop scan data that we have been given by our partners, and the bottom one is also processed through a just to control quite long scan around the housing estate and our office buildings. Motorway applications as well, side of the motorways, of course, with the control points along the way. Underground mines and caves, open pit mines, that has been also used to test and to produce the results from adjust to control so far. Underground tunnels that can also then, if you have a control points in the tunnels, you can mark them in the way how I described earlier and then perform the rigid or non-rigid registration for it. So that can be very helpful in the underground environments as well. So data example, I thought that I will show you one example of the data with actual already results, so not a workflow as such, just to give you an idea of the influence of rigid and non-rigid for that. So this is a scan of the housing estate with the open loop method, where the start of the scan is here, the end finish is on the other side. It is around 500 meter stretch captured with 9 control points placed, which has been used for reference points, so 9, and many others for additional evaluation or accuracy check. So points that we haven't used in adjust to control calculations, but that can be then imported to the result point cloud and check the positions and accuracy of those of that point cloud process. So we have manholes, edges of the pathways marked during that capture. So there is a clear improvements between rigid and non-rigid adjustment when calculating that data in Hub. So we can see rigid results, we have around 17 centimeters, and non-rigid comes to 4 centimeters RMS. There are some things that we are working on, like weights and changing weights, which is not available in that version, but that can also play a part on how important the control points or those constraints will be in SLAM processing. So as I mentioned, we do see a bigger impact and much on open loops, which can exhibit some drift because of the open loop itself scan. So here I wanted to just show you just 2 points, because I think for those of you that are in the surveying industry, but not only, you might find it interesting to see the difference actually in a point cloud between those two rigid and non-rigid results. So I've selected 2 edges of the pavement that were marked by a GPS solution as well during the capture and not used during adjust to control, so they are externally points for evaluation. So we have a rigid that is coming from around 15 to 20 centimeters offset to the curb between the control points and the actual curb. And then if I show you the non-rigid point cloud processed with our adjust to control, we can see really good alignment of the control points to the curb. So this is the second example. Also around 20 centimeters offset, maybe a little bit less on that side. And here we have a difference. So you can see those points are offsetted to left. And then on this other example, which is just the change here is just the point cloud. The control points are obviously in the same positions. And the point cloud itself changes from rigid to non-rigid here. About the height check, it's actually quite also interesting to see on the Z, because there will be some drift in open loops on the Z as well. So we can see a rigid section of the point cloud with those control points in the middle of it, so slightly offset to fit the middle of the curve, whereas the non-rigid fits it much better and much closer to those control points, the point cloud. Okay, so I think I finished the first part of the presentation, so I'm gonna just go out of it a little bit. I see I'm getting lots of questions, so I might, okay, I think I will be fine to answer them at the end. That's fine. So going to GeoSLAM Hub, because I think it's good to see the workflow, even though there are quite a few videos that will show you that already before, but I think that's still good to be able to see. So this is the point cloud. This is a control points and the point cloud collected by one of our partners as well. I thought that it would be a good example because again, this one has extra control points that we can use to control our results. So a couple of corners of white lines have been collected, which have not been used for calculations of adjust to control. So how the control points have been delivered is in a CSV file. So this is not ideal format at that moment in that version of the software, where we have a point cloud, a point name, a northing, easting, and elevation. And then we have a couple of other columns that aren't necessary for adjust to control. But one of the things that is not correct, unfortunately, is the point name, because we do need a letter at that moment. It is not that it's not going to detect the name as a number, unfortunately, at the moment. So what I have done, I have prepared it for now manually to then have the control point and the easting, northing, and elevation for that processing. Here is just a picture of those extra coordinates. So here they have been marked on the corners on the car park data. So this is a first thing that you need to have. You need to have a control point of, first of all, reference points. And if you do want to check the accuracy or check the accuracy or evaluate the solution, really, you might want to have extra control points. But firstly, you need to make sure you have them for reference points, so you know which one is which. Then the data is processed in GeoSLAM Hub. So this is as normal. You would process the data, and if there's any need for adjusting parameters, you would do that first. So to show you the viewer, so to show you the point cloud itself, it is a closed loop around the office building, and you can visualize all of the reference points automatically on the point cloud. So I would always recommend to check those reference points before running adjust to control, because otherwise, you don't know whether they were all detected correctly. Sometimes, as here in that examples, we have 2 points that have been detected at the start and end, which aren't the reference points used in adjust to control. So that's important to just have that idea at the start, what reference point you can use actually in processing. Okay, so from the main menu, ignore for now those icons. The camera will be there because it always, if you have a camera connected. The other one is the icon for adjust to control. I have tested the data earlier just to make sure, so there is already icon of process, but we will do it one more time now. So from those 3 dots here, you can extend the menu to adjust to control. And that's how the interface looks like at the moment in the software. You do import the data through here and select the file that I've prepared for the reference points. So that should be okay. And then for each reference point, unfortunately, at the moment, all of them are listed here. So I am not able to basically, choose them out earlier or delete them out if I know they are not correct. However, here I can exclude them. So if I know that reference point 1 is not correct and I'm not going to use it, I just exclude that point. And then I will select coordinates of each of the reference point here. Of course, you don't have to have them in order. You can have more control points in that file than your reference points. So it doesn't have to be exactly the same and in order. However, I was preparing that file because the reasons I mentioned earlier. So that's why I prepared with only points that are used here. So I'm selecting each of the point. I know as well from a fact, and this can happen very easily for you, that point number 5 was also selected, actually marked on the wrong coordinates. So I need to exclude that point as well, because I don't have actually coordinates for that point. And then I progress through the next one, next one, and next one. You need to select something for each of the reference point, even though you don't want to use that reference point number 9, you do need to select either exclude, because this is not going to be active for you to calculate. So I'm going to exclude that one as well, because that's the beginning and end. And now I can select which transformation I want to do. Non-rigid will take a little bit longer because it needs to process the global SLAM. So I'm going to select rigid for now, and then and I'm going to do the non-rigid adjustment on live, because I do want to leave some minutes for questions as well. So what's going to happen when you press rigid, it straight away goes back to the main screen and it will start saving the data. So that will take a little bit depending on the size of your capture. So this was around 8 or 10 minutes capture. So it shouldn't take too much time as well, but it has to calculate the transformations. It has to save all of the necessary files. There are separate folders that are created within the project structure for that new calculations. And again, that is all available in user guide, so you can refer to it. So what happened now, it has here, it popped out the notification on the bottom. I can go to my button here, my bell, and I can see my adjustment from reference point successful. And actually I can already see here what my RMSs are from that calculation. To actually see it in a better view, you just click on that icon under the data set, and you can see each control point with target coordinates, actual coordinates. Actual coordinates are coordinates of the reference point after transformation. So that's how the error is calculated between actual and target. Again, that is explained in the user guide too, so hopefully that will be useful for those of you who want to know more about errors and how to calculate them. And then we have error for each of that point separately, and then overall RMS error at the bottom here. From here, you can select Save Export, and you can save it in your desired folder. So I'm just going to create a rigid folder and say report. So that will be in a text file, which is easily imported to Excel for calculations. It is not yet in any pretty way or any PDF version so far. So I can open that in text file. So that is exactly what you have just seen on the viewer, or I can very easily import it to Excel, and that will, you can use that for calculations. The last thing that you would do normally is to export that adjust to control results. Here in the viewer, you still have your original data. So adjust to control does not change the original results in viewer or in the main project structure. You will still see your original local results. Whereas to actually use the point cloud and trajectory from adjust to control, you do need to export it from here. So I'm going to export it here, select the folder and export. And that is very quickly because you're just copying the data that's already in the project structure. Those data cannot be run through normal export options. So smoothing and other things cannot be added to that last file. Okay, so that was all the workflow. I think I did create already a draw version of that project just to speed things up. So this is already, as you see in the new coordinate system, you can select that when you create a draw project, you select that file. And this is also imported extra control points not used for performing just to control for the check. So you can see, I hope it's not that good contrast, but I think a few of them were very nicely visible, the corners of those yellow markers on the car park. So this is also possible. You can import that in a draw. Okay, so because I'm looking at the time, so I don't want to get too much. I want to have time for questions as well. So I'm coming back here. And just few last slides, and we're going to answer questions that have been popping up in the chat. I've been seeing a lot of them. Good. So as a summary of the tool, we are using Adjust to Control. You can use Adjust to Control as a georeferencing tool, which is integrated in the Hub interface. Or you can use it as well as a control for SLAM solution and to correct global SLAM drifts and correct global SLAM solution. That tool, to be able to use it, you need to use reference plates during data capture. And we are still working on, obviously, on the improvement. This is a version 1, and it is it has a lot of good things, but we know there's a lot of things we want to improve. So that feedback is very highly appreciated from your side, as you will be using that on everyday maybe basis, or your customers will be. Ongoing, what is ongoing with that tool is to support adjustable weights for control points. So to actually change the importance or influence of those control points on global SLAM, or increase it or decrease it. So if you have low accuracy control points, maybe lower weight can be put on them and still produce good result, or other way around, maybe you would want to put a higher weight on the control point. So that means it has higher influence during global SLAM. So that is something ongoing. We are looking at supporting different mounts, so not only reference points. Hopefully we will be able to do that. There is a limitation at that moment because we are applying transformations that are calculated from the reference plates. And there are still ongoing work towards the workflows for merging multiple data set with the use of Adjust to Control. So that I mentioned very briefly that, so I don't propose that as a workflow at the moment, but it is something that it could be possible for repeated survey on the stockpiles or on the mine where you want to have separate data that will be coming and matching to each other. Okay, so the material, because I just want to make sure you know about that. Dealer Portal 1 and Academy 2, which we have data uploaded. Adjust to Control user guide, Adjust to Control intro presentation. So 2 things, which lots of those information that I have discussed today will be in those 2 documents. And there's a video introducing GeoSLAM with the Adjust to Control workflow as well, and frequently asked questions that we came up with, or someone already asked us that questions, and then obviously more and more the better. I have a link here, but I'm not gonna maybe link for now, as I think I want to finish quite soon. To give you time for those questions. There are also quite a good materials about the GeoSLAM draw. As I mentioned earlier, there are new videos and release notes on that part as well. So this is not a part of this webinar, but just so that you are aware of it. And here, frequently asked questions, as I mentioned, is quite a good set of questions that maybe you are asking already today, or it will come up on one point in your work. So last slide before going into questions are some of the frequently asked questions which I thought I will go through today, just so that maybe it will answer some of your questions already. So can Adjust to Control, can I scan for longer than 20-25 minutes with Adjust to Control? So the answer is not. Adjust to Control is not allowing you to extend more time if the data does not process because of very long, extensive period of time that you have scanned. The Adjust to Control will not be there to fix. We will need to process data and try to process it in the normal standard ways of trying to troubleshoot it. However, Adjust to Control does not have influence on extending the scan data or capture time. Can I scan areas with not many features and basically poor feature environments? Again, I hope you kind of have now idea of the Adjust to Control. It is not correcting any large drifts or slips, especially not correcting anything that happens in the local stage. So if SLAM has lost its orientation during the local stage, it will not influence that at all. So really, you do need to follow the best practices still for SLAM. Can I merge data set after performing Adjust to Control? Unfortunately, in that version of Hub, this is not possible. So if you do adjust to control, as you saw, you need to export that last file and trajectory to a folder to your computer, but you cannot use that data back in Hub to perform another operation on the data. So the same comes with the coloring. You can do coloring and then perform georeferencing in other software potentially packages, or just perform adjust to control in Hub. Can I use adjust to control to align multiple scans together? So that was actually also a question that popped up on some point, and the answer is yes, but the workflow is still ongoing, so it is not finished. But that is an idea that you could potentially also use it for stockpile measurements, construction, and other areas where you would want to align multiple scans with only selecting few reference points. Okay, so just the last one to summarize. I think I have talked a lot about that, but adjust to control can correct a global drift, and it actually works pretty well on that. And we have seen a lot of good influence on, especially on the open loops, or where we have noticed bigger drifts in a global stage. The local stages, so anything that happens as you go, and if there is any large drift, then not, but anything that is across the entire project that is possible to correct with adjust to control. Right, all of those questions actually are also on the website, so I have actually gone really quickly through them, but there is a little bit more extensive answers to all of them as well. Right, so now is the time for looking in the question mark. Let me have a look what I can answer, because I am seeing quite a lot of questions, but that's very good. So, okay, so one of the first question I see, when using adjust to control for measuring road, how far between control points is recommended? So here, yeah, as I mentioned, there is some general rules of the density of a control points between, I would say, 50 to 100 meters maximum, but it really does depend on how many also features you have in the field, and if it's like just open side road, it might struggle a little bit. But and also the accuracy that you need to get to. So as more control points, obviously you will get a little bit probably better results, or you will have a little bit more contingency of the reference point. But between 50 to 100 meters separation, I would say. Okay, what type of reference plates are required? So there are two reference plates that we supply. I mean, they are the same principle, but they are different sizes. So for Horizon is a little bit longer and bigger, and then for Revo, of course, smaller. And those are provided by us, and systems will be coming with reference plates since from when Hub 6.1 is released. Okay, so the other question I think I've answered before already. During getting the reference point, should the scanner be perpendicular on ground or can be inclined on wall, for example? So I think I've answered that it can be used on the wall if it's Horizon scanner. If it is Revo or Revo RT or Go, that cannot be used on the wall. It has to be on the ground. Okay, question about you said that the unit needs to be kept upright and stationary for 10 seconds on control point. Was it that Horizon can also be kept stationary inclined? Yeah, so we can keep Horizon at the wall as well, and in the inclined surfaces. What about the roof of, I guess, that user already left. So here was a question about the roof, or I assume it was about the reference point. So as I said, Horizon can be used with an inclined position. As more inclined and more difficult, it will be more difficult to get the really good accuracy of that reference point detection. So I would be a little bit careful about that. Okay, here question. Do you get any problems when using the control plate to position over the control point, as you might take a few attempts to get the hole over the correct point straight away? Basically, the control point blocks the view of the control point. I think I understand what you mean. So actually to align the reference plate and to see in that star, so in the marker, to see the control point itself. So that shouldn't be a problem because we are detecting all of the movement of the scanner. So when you are trying to align it, you are still moving the system, and then the time of those 10 seconds help for the system, for the SLAM to then detect the correct position. So what we are detecting during that 10 seconds is actually XYZ in the center of our system. So it is not straight away on the ground. It is where the system is recording trajectory, basically. So we call it like reference point on the trajectory. And then obviously, as accurately as you manage to place that reference on the control point, that how accurately we can transform it to that control point. So yeah, it can potentially influence if you don't align it correctly, but the beginning of aligning it, because you're still moving, it shouldn't have that much influence, really. Any ideas or any feedback about the reference plate, please do let us know, because we would like to also hear that, what we can do to improve that experience as well. Okay, question about, have you had a scenario where the additional constraints from the non-rigid option caused the SLAM to fail? So we don't have a full SLAM failure, but I have seen a data that when the control points, either that reference points were not detected maybe correctly, or the control points themselves were a bit off or wrongly calculated. I have seen the results that have exhibit some problems in that result. So we are not touching our original results. So the local and global SLAM, as you process without adjust to control, will work, will stay the same. And that point cloud, which I've shown you, the export point cloud, after running some of the non-rigid with either bad coordinates or control points or bad reference points, I have seen some examples that maybe caused some misalignment in the data. But that would be very clearly visible, and that would be some very clear reason for it. So either the really bad control point, and someone missed the control points or placed the system on the wrong control points. And I think that is very easy to see. But yeah, so far that was the case, that it might sometimes exhibit some problems in the global, essentially in the point cloud. So you will see some misalignment, basically. Yeah, so the other question I think for you, Derek, as well is, that's correct, that the local SLAM is processed first, then the global SLAM is processed as well without those extra constraints. Then we recalculate the global SLAM only, so the end sort of optimization with those control points as a constraint, and obviously local SLAM has to be proved to be okay. That's correct. Hi, so here's another question about the control points, and they are generally in the roof. Is there a way of picking this up with a horizon? So I would really probably need to see some pictures of it just to make sure I understand how it looks. And essentially, yeah, horizon, as I mentioned, it can be used on inclined surfaces. It can lower the accuracy of that detection, because first of all, user might struggle a little bit more to keep that system stationary and stable. And of course, it's the easiest way of, as you might imagine, to apply correct transformation and do it all if it's straight up and flat. On the wall and all the other incline, it works well, very well, but it adds that uncertainty of that stability. So just I would be a bit worried about the stability. However, as I say, if you do send me some examples of photos of that environment, we can definitely discuss this more. I will show you my email address just shortly after that, and definitely please do send that. Okay, non-rigid sounds ace then. When would you not use it? I guess it's, yeah, I see what you mean. It might influence sometimes data depending on your control points and how good the control points are. It might influence it a bit, but you're right. If your control points and reference points are very well detected and good accuracy, then yeah, there isn't really that much problem in only using non-rigid. We run add video after we have run. Yeah, so Santosh asking about that, adding video after running control adjust. Yeah, so unfortunately, in that stage of that software, it is not possible to add a video to results from adjust to control. It is separated, so the results that you see in the hub, and even though you can run, I know you can run the video, you can add that video to your main solution, sorry, to your main results, which are the local results in the local coordinates, but you cannot add that video to that point cloud that I am exporting from adjust to control results. So this is unfortunately at the moment not possible. Yeah, the other question is about if you do adjust to control, you cannot export the point cloud as a shaded or smooth E57, say, yet. And that's correct. At the moment, we can't do that. We only have that option to export the LAS and the trajectory. So we are having a new trajectory, which actually is really good because we can perform some other things on it. But at that stage, not, and we are looking into it to enable more options, of course. Will it be okay to use open loop on the road? So again, here, depending what you exactly mean on the road, but we did have some projects that were used alongside the road on the motorway. We did have some projects that were used at the road or the housing estate, for example. It does depend how many features and how much other things are in the environment. But I don't see the main reason why not. But I would have to maybe see more what exactly you have in mind. But I think, Ben, you can definitely contact me directly and we can chat about this. But I don't see the reason why not. Okay, some good. Thank you for your feedback here. Good session. That's very good to hear. Is it possible to tell us what is the correct offset in the reference plate in the horizon? Yes, so we do have actually, we have offsets that you can see in the files that are produced during the reference, adjust to control calculations, and they will be in the file saved there. There are obviously, you know, if you use horizon with the inclination, then that inclination is accounted by our IMU and SLAM. So then the transforms will be calculated accordingly. But by the numbers, they are actually visible for the user in the files that we created during the processing. I'll just write that down and maybe add it to our material as well. Okay. All right, I think maybe last question because we are already literally just running out of time. So how still does this need to be kept from? Okay, one other question I will answer here is how still does the instrument need to be kept for it to record a point for 10 seconds? Could this be achieved on an extension pole? It might not be that that accurate, really. It is quite difficult on the pole, depending how long. We can run some tests on this. I think so, depending again on the accuracy you want to have and achieve, and that's why really also the reasons, for that specification of 10 seconds, because control points can be detected in a little bit less than 10 seconds. That 10 seconds is giving us a little bit more time for having a little bit more reliability on that detection. So depending, I can see that you are chatting here. So if the extension pole is not too big and you don't exhibit some, you know, because sometimes you might exhibit some movement on the top anyway, even if you keep it still, then potentially it can work really as well. we can chat directly about that as well. I'm happy to kind of help you to test it, or we can test it if we have something similar. So please do keep my email address, and I will have all of those questions back with me, so I can contact you as well directly. I think my email address is not showing on the screen. If it isn't, I'm gonna just show one last slide here. Just before finishing, please do send any feedback or any other questions that might pop up to your head later on to my email address. So it's Joanna.Setkovic, SETKOWICZ @geoslam.com. However, if you do send it to support or any other email, I am sure I will get that as well. And happy to answer any more direct or questions or planning for any of your different types of projects. So yeah, I think for today that's all, and thank you so much. Thank you for your good words. Thank you for all joining. It was very, very nice that I could share that with you. I think I don't have any more question here. And as I say, if anything else comes up later on, please do share that with us. Thank you very much, and have a good day. Rest of your day. Thank you so much.